Okay, today we are going to talk about relations and functions, and I have a definition here to start us, that a relation is a set of ordered pairs. And we know that our ordered pairs are always put into this form, where we have our x first and then our y in parentheses. So here we have a set of ordered pairs. This is a relation. So literally any set of ordered pairs that you have together would be a relation. What we're really going to look at today are functions. Now, functions are relations that assign exactly one output value for each input value. So we go to our function machine here, if you will. We have input that goes into the function machine. Let me show that better. Okay, and then we have output that comes out. Typically what we see is our x value going in, doing some sort of a function. Let's just call it, let's say we've got 3x plus 4. Okay, this will be the function. And then we put that x into this function, and then out comes our output, or our y value. Now there are other terms that I need you to be aware of. X is an independent variable. That just means that anything we want to put in for x, we can. Now, y, however, is a completely dependent variable, because y depends on what x we have put in. So our next terms that we need to remember are our x values are considered the domain, and the y values are considered the range. So let's look at how we figure out whether or not we've got a function. So I have my same relation here. So here's the relation from the prior page, and I've started drawing arrows. 11, the output is -2. 12, the output is -1. 13, the output is -2. And 20, the output is 7. Now notice that although two of my domains have the same range, this is still considered a function, because no two domain values share, no two domain values have different ranges. I'm totally not saying that properly. Let's just look at another set of relations. It is so much easier to see than it is to say. So let's look at a second set of relation. And we have -2, -1. We have -1, 0. We have 6 and 3. And we have -2 and 1. Okay, so when I set up my domain and my range, I have -2, -1, 6, and -2. Well, we're not going to write that again because I've already got that. And then I have -1, I've got 0, I've got 3, and I've got 1. So this -2 has a range of -1, but it also has a range of 1. Okay, this goes straight across here, this goes straight across here. So this too has two different values of output. Well, that's totally impossible if you have a function. Okay, let's just go back to the function that we put into our little machine, which was 3x plus 4. 3x plus 4. Okay, if I put -2 into this, 3 times -2 plus 4, this is -6 plus 4, which equals -2. Okay, not one of these answers, but let's not worry about that. Okay, now there is absolutely no way that if I put -2 into this function, I would get any other answer other than, well, actually, I could put -2 in and I got -2 out. Well, that's kind of crazy, but it works. So I will never get another answer. So this group, this relation is not a function. Now, there's actually an easier way to see it by graphing these points. That's one of the reasons why I am working on this. So let's say I have got points, and let me go ahead and draw a coordinate plane. And let me just put some points on it. Okay, what I am going to show you, oh gosh, you can't even see that. Okay, there we go. Okay, there's my coordinate plane. So what I am going to show you is the easiest way to tell whether or not this is a function. We're going to use the castle to be able to show this. So I am going to take my pencil, or my castle, and I'm going to move it along my x-axis. If my pencil crosses the path of more than one point at the same time, I do not have a function. But so far, I'm only passing one point. So what you see here is a function. So this is a function. Now, what would happen if all of a sudden this point showed up on the same graph? Well, as my castle would come across, when it would get here, notice it would now hit 2 points at the same time. This, therefore, now becomes not a function, okay, because of those 2 points being in the same line. This is called the vertical line test. The vertical line test is one of the easiest ways to tell whether or not you have a function. So you have both ways to look at it. And we'll be doing some problems with that tomorrow when you come in. So the other part of this is evaluating functions. Evaluating functions. Okay. And when we evaluate functions, quite simply, it's what we have done in the past, where we are taking y equals 3x plus 4. Okay, this is considered our function. Now, we also have function notation. When we use function notation, all we are doing is replacing y with f of x or something similar to that. This is just saying the function of x. Function of x. It is used the same way. It just replaces our y, but this is called function notation. We are going to be making tables using this function notation. So if we have, let's say, y equals 8 minus 3x, the way we're going to work with these functions to start is we will have a table that shows our x value, and then our function, 8 minus 3x, and then our y value. And I like to use, the book is going to use different ones. I like to use -1, 0, 1, and 2. The book will sometimes ask you to use 1, 2, 3, and 4. And all we're doing here is saying 8 minus 3 times negative 1. Okay, so that's going to be negative 3. So 8 minus a negative 3 is 8 plus 3, which is 11. 8 minus 3 times 0. 8 minus 0 is 8. 8 minus 3 times 1. 8 minus 3 is 5. And then 8 minus 3 times 2. 8 minus 6 is 2. Okay, so that's going to give you your chart of values. So just pretty much follow whatever the book wants to use. When they ask you to find the range, and let me move this. The bell's going to be ringing soon, so I'm rushing. Find the range. If they give you a domain, let's say they say f of x equals x minus 6, and your domain is negative 2, 0, and 5. All you're going to do is say then f of x equals negative 2 minus 6, so f of x is equal to negative 8. And then you'll have actually, we could have put our negative 2 in there. We could say f of 0 equals x minus 0, or 0 minus 6. Sorry, I've lost track of what I'm doing. When I'm rushing, it's not as good. Stop rushing! Okay. This equals negative 6, function of 0. And then I also have the function of 5, still rushing, x minus 6, so that's 5 minus 6. And so function of 5 is equal to 5 minus 6, negative 1. So now I just go back and I do the same thing with my range, and I say I've got negative 1, I've got negative 6, and I've got negative 8. And that is my range. So that is it, and hopefully, even with my mistakes and my rushing, hopefully you understand it all. Thanks, and see you tomorrow. There's the bell.